Hello, my name is Jacob Zamora, and this video is for Western Nevada College Economics 100, the teaching project. In this video, I will be covering how to measure income inequality using the Lorenz curve and the Gini coefficient. The Lorenz curve is named after Max O. Lorenz, who created it in 1905. The first thing to note is that the Lorenz curve serves as a visual representation on income inequality, while the Gini coefficient serves as a mathematical example of income inequality. When constructing the Lorenz curve, the y-axis is always the percentage of income in a country, and the x-axis is always the percentage of the population in said country. The line through the middle is a representation of perfect income inequality in a country. So if the Lorenz curve matches said line, then the country has perfect equality and faces no problem from perfect income inequality. The graph on the screen is an example of a Lorenz curve for the United States in 1968 and in 2010. This will be the first graph that I cover in this video, and I will be using the information from the left for both 1968 and 2010 to explain the graph on the right. As you can tell from the key here, the blue line represents income inequality in the U.S. in 1968, and the red line represents income inequality during 2010. As you can tell, the red line stretches out farther, so income inequality has gotten worse in the U.S. over the years. Now going over here to the information, we use the lowest 20%. The lowest 20% in 1968 only earned 4.2% of total income, while the highest 20% earned 42.6% of income in the country. In 2010, the lowest 20% earned 3.3% of income, and the highest earned 50.2%. So obviously the income, as you can tell from the graph, the income inequality has progressively gotten worse. And we can also infer from this graph that the top 5% in the 1968 and both in 2010, or in 1968 earned 16.6%, while in 2010 they earned 21.7% of total income in the country. As for more information on this income inequality, you can over here in the lower right box, the lowest 20% only earned $18,251 in 1968 and $20,000 in 2010, while the highest earned $180,000. For another example of the Lorenz curve, I will be switching over to the Lorenz curve in Brazil. This information was gathered from Brazil in 2009, the income distribution in Brazil in 2009, and as we can tell, it is slightly worse off than the United States is. The lowest 20% in the country only earn 3.2% of total income in Brazil, while the richest earn 58.5% of all income in the country, showing that their income inequality is progressively worse compared to the income inequality in the U.S. However, for Brazil, it has gotten better since 2000, as in 2000, the lowest 20% only made 2.7% of total income, which is now 3.2%, or at least 3.2% in 2009, while on the other hand, the highest income group has lost most of its share, dropping from 62.3% to 58.5% from 2000 to 2009. The next example I will show is the Lorenz curve for Bolivia and Haiti, which is on the Investopedia website. Now, as you can gather from the graph, the income inequality in Bolivia and Haiti is a serious problem. Bolivia is in the darker blue, while Haiti is in the lighter blue. The information from Bolivia is from 2015, while the information from Haiti is in 2012. Now, what we can gather from the graph is that the 20th percentage only makes 2.01% of all income in the country, while the 90th percentage makes 52.18%. While in Bolivia, the 20th percent makes 3.83% of total income, while the 90th percent makes 66.62%. The 47th percentile in Haiti is 10.46%, while in Bolivia it is 17.42%. So as you can gather from the visual graph, as I mentioned at the beginning of the video, that income inequality is a serious problem for Haiti and Bolivia. Now moving on to the next part of the video, I will be covering how to measure the Gini coefficient. To explain how to gather the Gini coefficient, I will go back to the graph for the United States for 2010 and 1968. The Gini coefficient matches how much distance there is between the Lorenz curve let's use 1968, and the line of perfect equality. So from here to here, compared to how much distance there could be. So from there to there. The equation to figure out the Gini coefficient is section A, which will be from the line of perfect equality to the Lorenz curve, 1968, divided by section A plus B. Section B will be how much space there could be. So from the 1968 over to here. So this is section A, this is section B, section A divided by A plus B. The result will be between 0 and 1, with 0 representing perfect equality and with 1 representing perfect inequality. In the US during 2010, the Gini coefficient was 0.457, while in 1968 it was 0.359. What that translates to is 35%, 0.9. And the same for 2010, 0.457 translates over to 45.7%. The Gini coefficient for the US during 2010, 0.457, is close to the middle between perfect equality and perfect inequality. As sort of a visual representation, if a country's Gini coefficient became out to 0, it would represent the line of perfect equality, so it would be straight across the graph. However, if the Gini coefficient for the country came out as 1, the line would go straight across to here and then straight up, showing that the top 20% own 100% of all the income in the country. Now I will head back to one of the previous web pages I used, which I used to explain the Lorenz curve for Bolivia and Haiti, to show that it has a map that shows the Gini coefficients, the percentages for each country in the world. So for the U.S., 45% for 2007, Mexico is 48.2%, and Brazil is 49.7%. Generally, some of the poorest countries in the world, such as the Central African Republic, have the world's highest Gini coefficients, 61.3%, while some of the wealthiest, Denmark, have 28.8%. This obviously meaning that the rich control most of the money in the countries, such as in South Africa, which is 62.5%. And this is how the Lorenz curve and the Gini coefficient works. Lorenz curve is a visual representation of income inequality in multiple countries, such as the US, and the Gini coefficient is used as a mathematical representation of this inequality.